This lesson looks at graphing what we call reciprocal relationships. And probably the best thing to remember when you think about reciprocal relationships is when one thing gets bigger, the other thing gets smaller. That's what we mean by reciprocal. So what does it look like? It looks like y equal to k over x. For example, y equal to maybe 2 over x, because k is some sort of constant number. It could be 5 over x. Here it's 100 over x. Here it's minus 5 over x. All of these are what we call reciprocal relationships. And what they've emphasized here is that an increase in one of the variables, so there we go, an increase in one of the variables causes a decrease in the other, and vice versa. So if the other variable goes up, this one goes down. So it's sort of like a reverse type of relationship. And they say, let's have a look at a possible example. Consider an example of a reciprocal relationship between the speed and the time given for a given distance of 120 kilometres. And I think you can see that the faster you go, the less time. So speed goes up, the time taken to do the trip over a set amount of distance would go down. So looking at this as an example, I'll just pop over to the next slide. Here we go, where it works. It says complete the given table, and we've got the speed. Notice the speed is getting less, and what we're saying here is that as the speed goes to 120, then the time would be, now remember, 120 kilometres is what we're travelling, and if we're travelling at 120 kilometres per hour, obviously it would take 1 hour to travel that distance. How has that worked out? Well, let's write down a few things you need to remember. D, distance, is equal to speed times time. Now that is a formula that you need to remember. Distance is equal to speed times time. So if our distance is 120 kilometres and we've got our speed times our time, if we're wanting to work out time, remember we can rearrange this formula, divide both sides by s. Now you have to think back to your algebra. They cancel out. So time here is equal to 120 divided by speed. And that's why, in this particular case, if we've got 120 as speed, then we could say that S, if that's 120, the speed, then T must be 120, there it is, 120 over the speed, 120, which is equal to 1. All right, in that case, 1 hour. And we write the 1 in there. So if we keep doing this, you'll find out that you can get solutions to each of these empty boxes. So if you have 120 divided by a speed of 80, it actually comes down to 1.5. It takes 1.5 hours. If it's 60 kilometres per hour, it will take 2 hours, obviously, because 60 and 60, that's 120 kilometres, 2 hours. Okay, here we go. 40 kilometres every hour, 40 kilometres per hour will take 3 hours. At 30, it will take 4 hours. At 20 kilometres, it will take 6 hours. At 10 kilometres an hour, it'll take 12 hours. And at 5 kilometres an hour, it will take 24 hours. So we end up noticing that as the speed goes down, then the time taken to complete the journey obviously is going to go up. So what does this look like when we plot it on a graph? Well, let's have a go. We need to put, let's say, we'll put time down here and we'll put speed up on this axis. So if we've got, let's say we go in twos here, 2, 4, 6, 8, 10, 12. And up here, let's go up in, we've got to get to 120. So maybe we'll go up in 20s. 20, 40, 60, 80, 100, and 120. Now, I'll take a different colour pen here just to plot this. So we'll plot it maybe in green. And I'll just bring this down a little bit so we can see the points. But plotting this, if we've got 100 or time of 1 hour, then the speed must have been 120. So that's going to be up here somewhere. If it was a speed of 80, so that's 120, drop it down to 80, it would take 1.5 hours. Wait on, sorry, that should actually be over there. Let me just, there we go. That would be 1 here, so that would be on the line here. So we're actually not going to go right to the point. It'll just be about there. And then we're going to go to 2. So we'll move this more than 1 unit away. All right, so it's just off the edge a little bit. And then we're going to go to 80 again, sorry. And so 80 would take 1.5. So we'll put that in around about, there's 80, so around about there. Better just ignore that one as well. So there we go. We'll go to about there on 80. Very good. On 60 kilometres an hour, that's this one here, it would take 2 hours. So we'll go to here. 40, there's 40, it would take 3 hours. So let's put it about there. At 30, it would take, there's 20, there's 30, it would take about 4 hours. Here we go here. Interesting how these dots are getting closer and closer. At 20, it would take 6 hours. At 10 kilometres an hour, it would take 12 hours. So maybe somewhere up here. And at 5, it would take 24. It's way down here. So in fact, when I plot this, this is the type of shape that I get. It comes down here, cuts through those points. I'm going to try that again because that doesn't look very neat, does it? It's got to actually go through as carefully as I can through the points. So there we go. Cuts through these points. Cuts down here. And you get a graph like this. That's called a reciprocal relationship. As the speed decreases, the time taken to do the journey increases. A nice reciprocal relationship. Now you need to practice drawing these, and then we can start discussing the implications of these to real life situations.